Crossing the road here in the Philippines can be quite an adventure. For me, it's the beginning of a quest into the unknown. I'm here on the Island of Palawan in the west of the Philippines to explore a mountain that has no name. It's located down in the south of this island, and for all records and all intents and purposes, no botanists or zoologists have ever been to the mountain top to discover the wildlife that occurs there. My name is Stewart Mcpherson. I'm here to hunt for these carnivorous, flesh-eating plants. They're called nepenthes, or pitcher plants, and they grow right across Southeast Asia and beyond. Their elaborate and colourful traps are irresistible to insects and other small animals. And so far, 130 different species have been discovered across this region. Each one of them has its own unique trap shape and structure, but the end result is all the same. They attract, capture and eat small insects, slowly digesting them inside their pitcher leaves. And there are many more species of these remarkable flesh-eating plants waiting to be discovered. For decades here in the Philippines, vast mountain ranges that have been too dangerous to visit because of political violence or their sheer remoteness are now becoming open to explorers like myself. And more new nepenthes species are being discovered at a faster rate than ever before. The humid tropical climate of the Philippines is an ideal home for them. No wonder more new nepenthes species have been discovered here than in anywhere else in the world. And even the local cabbies know of their extraordinary reputation. Mice! You could find a flower-eating mice! Wow! A flower that eats mice! Wow! So there's pitcher plants in the area. And he's not joking either. I took this photo on an earlier trip to Malaysia. This mouse was trapped inside this pitcher plant. It never stood a chance. The truth is, though, much less dramatic. No nepenthes or any other carnivorous plant truly eats vertebrates. It's just that the larger nepenthes are occasionally lucky enough to trap and kill a rodent by chance. And it's on this island that you find some of the biggest flesh-eating plants of all. Big enough to put your whole arm in, as I discovered on a previous trip. In fact, I've been lucky enough to discover 5 new species of nepenthes just over the past few years. And there are hundreds of other mountains in this region that have yet to be explored, with who knows how many new species awaiting discovery. The mountain that I want to climb lies 3 hours south of here. It's next to a huge mountain complex called Mount Victoria, and that in itself was only ever climbed and explored for the very first time just 3 years ago. So it's extremely interesting virgin territory. As I headed south, I caught sight of my goal. A huge mountain system rearing up in the distance. Even the roads don't go that far, and when they run out, you enter wilderness. But even here, in this remote village, I was greeted not by the sounds of the jungle, but by an ice cream cart. Civilization has a long reach. Here I found 6 local hunters to help me as guides and porters. We soon left the village behind and pressed on. The men had cleverly built their own backpacks to carry our supplies. They told me they knew a path to the foot of the mountain, but no more than that. No one had ever climbed it. They didn't even know an ascent was even possible. the trails got narrower and the jungle started to close in on us. When the path ended, we followed faint trails left by the hunters and their game, and then we came into raw jungle. After a long and exhausting trek, we set up camp for the night on the banks of the last great river. And at that moment, we caught a brief glimpse of our destination. A huge steep-sided mountain lay before us, shrouded in cloud. The next day, we left the rivers behind and followed more trails. And then we began to climb. The undergrowth crawled with leeches, waiting for a passing animal to be their next meal. Instead, they dined on us. It really looks worse than it is. It doesn't hurt as they suck your blood, and they're easy enough to remove. But they secrete anti-blood clotting enzymes, which means that the wound bleeds for many hours. This was a pretty hostile environment. The plants here were all ready to draw blood, laden with sharp spines.
We've climbed up to about 450 metres or so and encountered our first pitcher plant.
This one.
Yes. Remember the fat bottom one? It's a good sign to see that the mountain's wet enough to harbour pitcher plants, and so a good sign for what's on the mountaintop itself.
As we continued, it soon became apparent why the hunters struggled through the lower slopes of the mountain to come here.
They collect this, which is the resin of the agatis tree. By carving these parallel notches into the bark of this great tree, they drain the resin that flows down and they chip away at it and collect it and bring it back down to sell in the lowlands. A kilo of this resin would cost at the market about 20 pesos. That's about 50 US cents or about 30 British pence. It's used for a whole range of applications, but the most important out here in the forest is for starting fires.
It burns with a bright, powerful flame, even when wet. And so it is used by locals as an essential tool for starting fires, and it can even ignite green wood. The giant agatis trees have become critically endangered because too much resin collection kills the trees, and so the decline in numbers has caused a vicious circle, with the remaining trees being harvested with increasing intensity and frequency, killing more and more trees each year.
We've just come across also this snare trap for catching small animals, perhaps even birds. It's quite clear to see how it works. There's a bent twig that acts as the spring and a small trigger system with these 3 sticks in the middle. And once that's released, it basically pulls together this rope in the middle that ensnares around the animal's leg and basically keeps it captive at this point until the hunters then come back and collect it.
For our second night in the jungle, we made camp next to a small stream. We still had enough food for 7 more days exploring. The guides insisted we now had to carry our own water supplies. They didn't know if there were any more streams up on the mountainsides. The next day, our climb began.
This is our 3rd day of climbing and we've reached up to about 1,100 metres or so. As you can see, the vegetation has changed abruptly. We've left the lowland rainforest and now are in this montane scrub consisting of small trees. It looks really good Nepenthes habitat, but unfortunately it looks a bit too dry as well. We haven't seen any other species up here, so we're waiting really for the ridgetop.
Even up here, though, there were small signs that people still do come here.
By the looks of things, it's very recently made. The leaves are still green. As you can see, everything here has been made from products from the forest. It's bound with twine and rattan. It's thatched with the palapa leaves, the rattan leaves themselves. As you can see, the hut itself is remarkably sturdy. It's weaved together with the rattan itself, and this probably can take 2 or 3 people quite easily. The weaved roof itself is very, very secure, very, very watertight. It's actually weaved in multiple layers, bound together very, very tightly. So it's easy to imagine that this shelter would make an excellent place to sleep on these exposed and windswept hillsides. All around on the outside of the house, there's small heaps of rice husks. So clearly they would have brought up the raw rice to sustain themselves for several days, perhaps even weeks. And down here in this little branch, there's this hollow with this pounding stick that I found just here. And so it seems very likely that they would have pounded the rice, perhaps to make flour, to put together bread, or perhaps other small loaves.
Later, I was told that the shelter was most likely built by the Taut Batu, an indigenous tribe from this area. This was the last trace of human presence that we would see. There were no more trails to guide us. We came across these strange, bright orange crabs. There have never been any reports to date of these land crabs at such high altitudes.
We're really close to the summit now. Our guides are forced to machete a trail right in front of us. At the moment we're clearing a campsite area to actually put up a base before we try the final assault through this dense, impenetrable bamboo forest.
And just before the rain arrived, we finished setting up our summit camp. The night was to be cold and wet on this humid and mossy mountain slope. For breakfast the next day, everything was wet. With a small supply of resin, we managed to start a fire. And I managed to dry out my camera. The guides sharpened their machetes before we set out, and I climbed on to see what lay ahead. We were on a ridgetop that continued off into the distance. We would have to head along to the summit of the ridge. That's easier said than done. Thankfully, the guides had sharpened their machetes.
Our local guides have macheted this trail across the ridgeside. It goes on for about 1 kilometre or so. This area is just completely unexplored and uninhabited. There's no hint of a trail, no hint of a path. They've just simply macheted straight through the forest. It actually makes it quite difficult because as you pass through this trail, all the remnant sticks that are cut off at angles are incredibly sharp and absolutely lacerate your legs. So it's not easy to navigate across this exposed ridgeside habitat. And we've just reached the cloud forest on the slopes of this mountain. We've also started to encounter our first pitcher plants. Here's one, and there's many others all around me. It's quite difficult to determine exactly what the plant is because it's growing at the very bottom of its altitudinal range and it's struggling to survive. So we have to climb up higher to determine really what it is. The problem with this ridgeline is that it's just too vegetated for the pitcher plants. We've got to get to a more open spot and find out where we can go. All along this ridge, there's nothing but trees. It's too shady, too dark for the pitcher plants. But out there I can make out a perfect peak. A big rounded shoulder standing 200 or 300 meters above where we are now. That can look really, really good. That's where we've got to go for.
But suddenly and unexpectedly, we emerged from the impenetrable forest into the middle of a highland swamp. Our guides had never seen anything like it before, or even heard of one around in these mountains. If true, it meant the area had truly never before been explored.
It's really interesting when observing the vegetation. From the south where we've just come, the vegetation consists of these big trees. It's much denser, much thicker. But as we progress over to this new peak that apparently has never been climbed, it is much sparser, much thinner, much lower, which might suggest that it's an ultramafic peak, which is really, really good for pitcher plants. So that's another very good sign that we've got an interesting area to explore. It's a small carnivorous sundew. It's called Drosera ultramafica. This plant's only known from two other mountains on Palawan, Mount Victoria and Mount Mantingahan, and these are by far the biggest. They're quite distinctive because they form a tower, and so it holds really good hope for what's up on the mountain summit itself. So we've just got to really keep on exploring. It's clear that something has been living here. There's these massive flattened out areas. The only animal large enough to do this here on Palawan is wild boar, so perhaps this is a population of wild boar living up here as well. There's no more pitcher plants here. We've got to get right up onto the top of this hillside up here, this big peak. There we stand the best chance of finding something, whether it's new or known. The only way to find out is to get there. And here is the first plant that we've seen with pitchers. These are the basal pitchers, or the lower pitchers, produced by young plants growing on the forest floor. It's really quite interesting because these traps are similar to species of pitcher plants growing in Palawan, but they're a little bit different. They're much squatter, and the structure and the coloration is a bit different as well. So it does give hope this plant could be a new species, but really we have to see the upper pitchers and other plants growing in full sunlight to really be sure. And here are some other pitchers. These are produced from leaves that emanate along the length of the stem, so as the plant climbs up to the canopy. They're generally more brightly coloured, often having more nectar, and generally attract more flying insects, particularly flies and wasps. And this allows the plant to really capture a different spectrum of prey up above the canopy, up in the upper reaches of the vegetation. Just a few meters still to the mountain summit, and it's very interesting to note that this ultramafic rock has eroded to form sheer blades. The whole mountain is covered with them. These knife edge ridges that markate the summit of this mountain really are as sharp as a knife, so if you were to fall onto them it could be very bad indeed. And climbing across the summit, it's easy to find this new pitcher plant growing everywhere. And just looking at this plant, here's a picture right here. Just looking at this plant, I can conclusively say that it's new. It's different from all of the other species from this island, and indeed from across the Philippines. The structure of the pitcher and the shape of the leaf are different from all of the other species known here. So it's clear to say that this plant is new to science. After exploring this population on the mountain summit itself, this is pretty much the largest pitcher that we've discovered so far. It's about 25 centimetres or so tall, and as you can see, brightly coloured with yellow, purple and green coloration. It's a spectacular new find and a really nice addition to the Nepenthes of the Philippines. It's interesting to observe that in each pitcher there's a whole ecosystem of life that lives in the trap and consumes the prey that the plant captures. In this trap in front of me I can see mosquito larvae, small spiders and a whole variety of other animals. And it's very possible that many of these other organisms living inside the traps could also be new to science. The pitchers look like flowers, but actually they're not. They're highly modified, highly specialised parts of the leaves. The plant will produce flowers, but only when it grows higher up into the canopy. The pitchers themselves are highly complicated structures to catch and kill insects and other small arthropods. The upper surface of the lid is brightly coloured, and also on the lower surface there's glands that secrete honey-sweet nectar. The combination of colour and the nectar attract the prey that climb up the rough exterior surface, or also by way of these wings down the front. Once they're at this opening or this mouth of the pitcher, they very rapidly fall inside because this rim or peristome is very slippery. Once they fall inside, they fall directly into the digestive fluid contained within the trap. They're unable to then climb up the interior and escape because the inner surface is covered with a waxy secretion, and also the inner margin of this rim is lined with long, really sharp needle-like spines that form a physical barrier to prevent the prey from climbing out. Once they're inside, they eventually drown and are digested by the acids and enzymes secreted by the plant. And the nutrients are absorbed directly through the wall of the pitcher and used by the plant for growth.
I observed the animals that visit the plant's traps, and which could conceivably turn into prey for the plants. They're attracted usually by the nectar and the colours of the pitchers.
And here is a flowering plant in front of me. As you can see, the flowers are borne on a long spike that emanates from the centre of the rosette. It's quite distinct from the leaves that bear the tendrils that produce the pitchers on the ends. It's quite interesting because these pitcher plants produce flowers of a single sex. Each plant is either male or female. This one happens to be a male, and it has a very sweet musky scent that's quite distinctive and unlike most other pitcher plants from the Philippines.
We found this previously unknown species of pitcher plant. It was unusual in that it produces black upper pitchers, a trait not seen in any other species of Nepenthes in the Philippines.
It's the morning of our 6th day and we're now starting our descent. It's been a very interesting experience exploring this ridgeside. And now really the great last frontier for exploration is this ridge point up here. We quite optimistically hoped we could cut our way right the way through round to that top, but it was simply impossible in the time that we had. But this last ridge north of the city of Nara is completely unexplored, and it holds very high hope that we found a new Nepenthes here. There could also be one up there. So that really is the next goal and the next quest.